Today we're going to look at recurring decimals and writing those as fractions. So all recurring decimals are called rational numbers and can be written in the form of a fraction. The idea in this is to multiply the decimal by a power of 10, so whether it's going to be 10 or 100 or 1,000, so that you move the repeating part of the decimal along a few spaces so that whenever you subtract it, the trail will cancel out. The general rule is if there's one repeating digit, so if it was something like 0.11111, where there's only one digit repeating, you'd multiply by 10. If there were two repeating digits, so something like 0.343434, and so on, you'd multiply by 100. If there were three repeating digits, like 0.123, 123, 123, and so on, then what we do is we multiply by 1,000. So in this example, we can see that the decimal is 0.569 recurring. Now in dot notation, we could write that as 0.5 with a dot above it, 69 with a dot above the 9. Now there's a bit more on that later. So what we need to do first is we call this decimal R for repeating or for recurring decimal. Because there are three repeating digits, because it's the 5, the 6 and the 9, they're repeating infinitely, we'll multiply by 1,000. So if we multiply R by 1,000, we get 1,000R. If we multiply by the decimal by 1,000, we'll move the decimal place 3 spaces over and we'll get 569.569569. Now there's an infinite trail of 569s, so by moving it along 3 spaces, 3 less than infinity is still infinity, so in this 1,000R equals 569.569569. There is the same number of 569s after the decimal point as there are in the original R value. So if we subtract them, all the numbers and the repetition all line up. So the 9 and the 9 go together, the 6 and the 6, the 5 and the 5, the 9 and the 9, the 6 and the 6, the 5 and the 5, all the way up till the decimal point. So whenever you take those away, they'll all go to 0. Then we've got 569, take away 0, which is 569. 1,000R, take away 1R, gives you 999R. And then if we know what 999R is equivalent to, we can divide by 999 to get what 1R is. So R is 569 over 999. Now we can't simplify this. There's no factors in common, so we have to leave it as 569. So the general way we do this is you call whatever the decimal is R, like we did here. You then multiply by either 10 or 100 or 1,000, depending on the number of repeating digits. You subtract the original from that form and then divide through to get what 1 of R is. A couple of other points then. So if R at this stage in the fraction was had a decimal inside it, what we'd do is we'd multiply top and bottom by 10 so that it removes the fraction. If there were a couple of decimal places, you'd multiply top and bottom by 100, and so on. And if the original decimal is greater than 1, it's easier to ignore that whole number at the start and then just deal with the decimal part, as we'll see in the next example. So the next example is 5.6898989, so the 8 and the 9 are repeating, so that's 2 repeating digits. We're going to ignore the 5 and say that R is equal to 0.6898989, and so on. So there's 2 repeating digits, so we multiply by 100. And if we'll get 100R equals 68, so we're moving the decimal place twice to get 68.989898. If we put in R equals 0.68989898 and so on, what we can see is that the 9s at the end line up, as do the 8s, as do the 9s, as do the 8s, as do the 9s, as do the 8s, all the way up to the second decimal place where the 8s line up. After that, we've got a 9 and a 6. They take away to get 3. 68 minus 0 is 68. And then we've got 100R, take away R, which is 99R. So 99R equals 68.3. Divide by 99 to get 1R, and we get 68.3 over 99. Now this is the bit where it doesn't look as a nice fraction, so 68.3 over 99 we don't like. So we multiply top and bottom by 10 so that it will get rid of the decimal. Because we're multiplying top and bottom by the same thing, it doesn't matter, it's just equivalent fractions. And what we have then is 683 over 990. This can't be simplified, so we just leave it in that form. But we need to remember that the question was 5.689. What we've done is 0.6898989, so we need to put that in as 5 wholes and 683 over 990. And that's what the answer would be. So we have a few more examples here to look at, and the first one is 0.111111111. So the first step we have to do is we say let R equal 0.111111 and so on. There's one repeating digit, the 1 is the only thing that's repeating, so we multiply by 10 and we get 10R equals 1.11111111 and so on. We rewrite the original as R equals 0.11111111 and we'll take those away. And what we can see is that all the ones line up, and whenever we take those away they'll cancel, and what we'll be left with then is 9R equals 1.0. Dividing by 9 we get R equals 1 over 9. So the fraction 1 over 9 is equivalent to 0.111111. Example B is 0.737373. So again we start off with let R equal 0.737373 and so on. There's 2 repeating digits, so what we'll do is we'll multiply by 100 and we get 100R equals 73.737373, and we'll take away the original R, which was 0.737373, and what we have again is that the 3's line up, so they take away and get 0, as do the 7's, as do the 3's, as do the 7's, as do the 3, as do the 7's, and we're left with 99R is equal to 73. Dividing 3 by 99 we get that R equals 73 over 99, and that can't be simplified. Example C, so we'll let R equal 0.12646464. There are 2 repeating digits, so we'll multiply by 100 and that will get us 100R equals 12.646464. We'll take away the original, so R equals 0.126464 and so on. What we can see then is that the 4's line up, and you take those away, they get 0, as do the 6's, as do the 4's, as do the 6's. But at this stage we've got 4 take away 2, which we obviously know is 2. 6 take away 1 is 5, put in our decimal point, and then 12 take away 0 is 12. So 100R take away R is 99R. To work out what 1R is, we divide 3 by 99 and we get 12.52 over 99. Now this isn't very nice because we've got decimal on the top. If we multiply top and bottom by 10, we'd get 125.2 over 990. Again, still not very nice. So we can multiply again, top and bottom by 10, and we get 1252, so 1252 over 9900. Now this can be simplified. Whenever you do that, that simplifies down to 313 over 2475. The last example, what we do is we ignore the 5. So we say let r equal 0.135, 135, 135. There's 3 repeating digits, so we'll multiply by 1000, and we get 1000r equals 135.135, 135, 135. Take away the original, r equals 0.135, 135, 135, and so on. Again, what we'll see is that the 5s line up, so they cancel, as do the 3s, as do the 1s, as do the 5s, as do the 3s, as do the 1s, and the 5s, and 3s, and the 1. So all the decimals cancel, and we're left with 135 minus 0, which is 135. 1000r take away 1r is 999r. So r equals 135 over 999, which simplifies down to 5 over 37. But what we were asked for in the question was 5.135, 135, 135. What we've looked at is 0.135, 135. So our answer then is going to be 5 and 5/37. And just a quick note about dot notation. If we have the decimal 0.11111, as we did in example A, what we can do is we can write that as 0.1 with the dot above the top. And the dot above the top means that this digit is repeating, and repeating infinitely. If we had the fraction 0.1232323, where the 2 and the 3 are the bits that are repeating, we can put a dot above the 2 and a dot above the 3. And that implies then that the 2 and the 3 are repeating. If we have 0.56791, 791, 791, we can see the first part of the repetition is the 7 and the last is the 1. So we'll put a dot above the 7 and a dot above the 1. And we get 0.567 dot 9 1 dot. And similarly then, if we had the dot above the 1 and the 4 in this next example, that means that the 1 is the first number in the repetition and 4 is the last. So what that's going to look like written out in full is 7.53 165 9824 165 9824 165 9824. So the 1 and the 4 are the first and the last in each set of repetitions. So we don't put a dot above every digit, so sometimes people come to school with that misconception, or that you could write it with an R above it to show that it's recurring, but those are not the case. The final thing then is to write fractions as decimals using dot notation. Remember, a fraction, what it means is the top divided by the bottom. So if we write it as 5 divided by 9, 5 goes into 9, well it doesn't, so put in a 0 and carry the 5. 9 goes into 50 5 times, remainder 5. 9 goes into 50 5 times, remainder 5. What we can see, it's always going to be a 5. So 5 over 9 is equal to 0.5 with a dot above the 5. 3 over 7 then. What we'll do again is we'll divide 3 by 7. 7 into 3 doesn't go. We'll carry the 3 into 30, goes 4 times, remainder 2. Into 20 goes twice, remainder 6. Into 60 it goes 8 times, remainder 4. Into 40 it goes 5, remainder 5. Into 50, 7, remainder 1. Into 10 once, remainder 3. And then we're back to the repetition. So 3 over 7 is equal to 0.428571, dot above the 1 and a dot above the 4.